So I have shown an experiment on here, and this is an experiment we can do in class. At some point we're going to be using this butcher paper or tracing paper, but I want to let you know that this paper is very thin paper that you can place on top of a figure and then use to show reflections and use to show transformations, because it's see-through and it's easy to fold and write on. Alright, so our next test is our next objective is to learn about reflections, and that we can reflect figures using graph paper or tracing paper. Alright, so this is what it looks like. If you looked in your book, it wouldn't have this on there. We pasted it on here to make it easy to see. Alright, draw and label line L on tracing paper, which we have. Then draw and label quadrilateral ABC with vertex C on line L. So there's ABC, there's vertex C on line L. That's what we have. Fold the tracing paper on line A, and then you're going to draw the image. So if you fold this paper, you can see it's folded on this line L, alright, and then you unfold it, you would get something. So I'm going to pretend we folded it, we've drawn this, and we unfolded it, right? This B would now be down there. I'm just going to draw it. This A prime, B prime, A prime would be over here, and our D prime would be down here. What we would get is we would get a figure that moves across that line and creates an identical. I know it doesn't look crazy identical because I kind of just hand drew that a little bit. Alright, so if we use a protractor, measure angles formed by each segment. This angle would match this angle over here would match this angle over here, and this angle here would match this angle here, and these two angles would also be identical. Alright, if we use a ruler to measure the segments, what do we notice? Alright, we're going to say angles are the same, and we're going to say segments are same length. And I'm going to mark a couple so you get used to seeing it. Like this segment here matches that one. This segment here matches that one. And they all match each other, but I'm not going to tick mark this up. Alright, so in this activity, when we fold on this line, that line is the reflection line. Everything jumps over this line. This to A to A prime, right? D to D prime. Alright. The student claims that the figures, a reflected image, lie on opposite sides of the line of reflection. Do you agree? Always lie. You know, I'd almost agree, right? The only thing that makes me not agree is this C, right? We're going to say no. Why not? Right? C and C prime are on the line, right? They're not on opposite sides of the line, they're on the line. Okay? We're going to talk about these things down here and be done with page 1. Alright? But see what a reflection is. It's a flip. Alright? Perpendicular lines that intersect at 90-degree angles. Alright? In the figure we can see these perpendicular lines, and I want you to pay attention to that mark. That mark right there, that right angle mark, indicates that lines are perpendicular. There's 90 degrees. It can go anywhere because once you have a right angle, they're all right angles. Alright? A perpendicular bisector is one that both has this 90 degrees, right? So a line segment is a perpendicular bisector to the segment at the segment midpoint, right? So if I can bisect it, that means A, and we'll call this C. AC is the same as CB. It's called a perpendicular bisector. All right. A reflection across line L maps point B to P prime. And when you reflect across the line, right, your distances are the same and it's perpendicular. Right? If I drew these points here, if I drew from here to here, it would be perpendicular here, and these distances would be the same. Alright, so anytime you reflect across the line and then connect the original pre-image with the image, you're creating a perpendicular line that is bisected by the reflection line. And that's kind of important to understand. Alright, we're going to stop there, and that's page 1.